Hello, welcome back. In this lesson, we're going to test the board support package we've written. So please download the project attached to the previous video. At the end of the previous lesson, I attached the board support package we've assembled so far to the video. You can check under resources and download that. Once you download it, open it so that we test it out together, and we're going to work together from here. So this is where we left off from the other time, and what I'm going to do is I'm going to come back to our board support package, and this main file, this main function that we wrote, I'm just going to cut it out and just create a main.c file for the board support package itself. I'll come here, I'll just create a main file here, and this we shall use for testing main. And then once that is done, then I'll just paste the main function I cut. And what I'm going to do next also is to include the LCD driver into the board support package, and I can just come to the lcd.h, this one here, cut it out, and then include it to bsp.h like this. So then we only need to call bsp.h. So what I'm going to do is call bsp.h in the main.c file that I've just written. I'll just copy this, I'll just paste it here. Right, so we can check that it all works by rebuilding. There's a problem. Let's see, we messed something up. Yes, so the error is from the lcd.h file. Instead of just copying the header file, the lcd.c file, sorry, instead of just copying the header file, we actually cut it from the .c file. So the .c of the LCD no longer has access to the interface of the LCD, hence the 28 errors. So we just need to copy and paste that. So I'll go back to board support package, this line here. So I'll just copy from here and put it into the implementation file of the LCD driver, and then I'll rebuild again, and everything should be fine now. As you can see, we've got 0 errors now, and the one warning is because of new line somewhere. So it looks good. Anyway, so let's move on. So how about we start with the ADC module? What I'm going to do is I'm going to call the ADC API that we wrote, and to verify that in fact we encounter the board support package, we realize that we've got an ADC API here called ADC1 in it. I'm just going to copy this. I mean, I could type it, but to show you how it's done, I'll just copy it and put it here. And we've initialized the ADC, and I could add the while1 loop here like this. And using the STM32 hardware abstraction layer provided by ST microcontroller, we could just start the ADC by saying HAL ADC underscore start. And then we know our ADC handler is called HADC1. We can verify that in the board support package because we already declared that in there, ADC1. And now we can say HAL ADC poll for conversion, which will start polling. And then we can give a timeout of 10 milliseconds. Of course, the reason for this is the typo here, sorry. There's a comma. And now we can create a global variable here to collect the ADC data. I'm just going to declare a uint32 underscore t here. Now call this sensor value. And what I'm going to do is sensor value equals HAL ADC underscore get value, and I'm going to put the ADC handler here again, HADC1. So next what I'm going to do is I'm going to connect my potentiometer to PA4 of the STM32 disco board. The middle leg of the potentiometer shall be connected to PA4, the other legs to ground and 5 volts. And then after that, I'm going to run the code, and then we shall go to the debug view to verify that indeed the ADC is actually working. Okay, so this is my setup. I've got my potentiometer. I've got the first leg connected to GND, the middle leg connected to PA4, which is the pin of our ADC1, and then the last leg connected to 5 volt. So that's how I've connected to my disco board. Next, we're going to the debug view to run the experiment and see how it turns out. So as you can see, as I turn on the potentiometer, the sensor value variable changes in the watch window 1. So yeah, the ADC module works. This to the leftmost, which should give us a value close to 0, and to the rightmost should give us a value close to 4095, because we're using a 12-bit ADC. So yeah, we know the module works. The value just jumping is just noise, but yeah, we can just tell. Yeah, so we'll move on to test the next module, yeah?